Now let's go ahead and do the second page here. Sorry, I needed to give you a unit conversion for this. So your mass is going to be 0.140 kilograms when you've got 140 gram mass. So we're pitching a baseball, and we want to know its speed when it'll leave the pitcher's hand. So we know this is the time. We know that this is the force. We've got a mass. So really using the impulse momentum theorem. Again, this is just an application of F equals ma to firing things, crashing things, and exploding things. So there's not a lot of thinking to do here. It's just a question of labeling your variables. So this is 4.5 times 10 to the negative 2, so that's going to be 0.045 seconds. So you might want to brush up on scientific notation, which I really don't use in this class, but for this problem it seems to have popped up. So then we'll have 0.14 times the V final minus 0.140 times, well, no speed at all. So our actual final speed ends up being 132 times 0.045 divided by 0.140. So when we actually solve for that speed, what we're going to end up getting is 42 meters per second, which I think that corresponds to around 100 miles an hour. I'll need to double check that. Now, when the batter hits the ball, a net force of 1,150 newtons opposite to the direction of the ball's motion acts on the ball. And we want to know what is the final velocity of the ball after it's hit. So we're going to use the same equation again. Ft equals mv minus mv initial. So we're going to end up having here, we're going to have 1,150 newtons times the time, which is 9.0 times 10 to the negative third seconds. But let's be clear here, the direction of the force is opposite to the ball's initial motion. So let's be careful here. So we're going to have m times v minus m. And the v here, let's be really careful. Since the force is in the opposite motion, I can write 42 newtons here for my initial speed, but then I need to be really careful to make this a negative here because the force is opposite to the direction of the ball's initial motion. And I want to actually just kind of label that right there. Let's keep going. We've got negative 1,150, 9.0 times 10 to the negative 3 equals 0.140 times V final minus 0.140 times 42. When we go ahead and solve for V, what we're going to end up getting is negative 4.41 meters per second. Now here's an interesting question. We know the force of the ball on, we know the force of the bat on the ball is negative 1,150 newtons. Therefore, the force of the ball on the bat is going to be the same 1,150 newtons in the opposite direction because of Newton's third law. So that wraps up the homework question. I hope that was helpful. And we will basically be appraising on both the energy stuff and the momentum stuff when I see you either Tuesday or Wednesday.